In this video, we want to take a look at some commands we can use when we're trying to verify an EIGRP configuration or troubleshoot EIGRP. Whether we're dealing with EIGRP or some other IP routing protocol, one of our most useful commands is show Iprout. This is going to show us the contents of the router's IP routing table, and it might contain route information from different routing sources. And remember that if different routing sources claim to know how to get to a specific network, the route that gets injected into the IP routing table is based on the routing source's administrative distance. Lower is better. A directly connected route has an administrative distance, or an AD, of 0. It's very believable because we're attached to it. And by default, even though we can alter this in the configuration, but by default, a statically configured route has an AD of 1. It's very believable as well. And if we learn a route via EIGRP, which we can see is indicated with the D, that route is going to have an AD of 90. Not quite as believable as a directly connected or a static route by default, but it's more believable than OSPF, which has an AD of 110, you might recall. Well, let's take a closer look at this route to 2.2.2.2. That's the loopback IP address of router R2. We see this 158.720. What is that? That's the metric. Remember the metric calculation? That's the metric, or that's the feasible distance to get to 2.2.2.2. The way we're going to get there is by going to a next hop IP address of 10.1.1.2. In other words, to get to this loopback IP address, we're going to go over this LAN link to R3 and then down this LAN link to R2, rather than going over the much slower WAN link. And to get to our next hop of 10.1.1.2, we're going to go out of R1's Fast Ethernet 0/1 interface. That's how we interpret that information in the IP routing table. But remember, just because we see one route learned by EIGRP in the IP routing table, that doesn't mean that's all of the routes learned by EIGRP. There might be more. We can take a look in the EIGRP topology table with the command show IP EIGRP topology, and we can see that we know about a couple of ways to get to 2.2.2.2. We could get there via R3, or we could go directly to R2. Why are we going via R3? Because the feasible distance of the path via R3 is less than the feasible distance of the path going directly to R2, which is nearly 2.3 million. We're going to go with the best feasible distance, unless, if you remember, we configure the variance option, which says that the best feasible distance can vary by a certain factor that we specify, and then anything in that range, all the way up to and including the best feasible distance times that factor, any of those values will be acceptable for us to load balance across. Now, what's the number after the feasible distance? You'll notice here we have a little over 156,000, and here we have 128,000 and change. What are these numbers? These are advertised distances. The advertised distance is what the neighbor is advertising to us. The neighbor is saying, I'm this far away from this network. However, in order to get to that neighbor, it's going to cost us something. There's a distance from us to the neighbor. So what we do is we add up the cost from our router to the neighbor, and then we add on the neighbor's advertised distance. That gives us our feasible distance. This is one of 3 tables that EIGRP maintains. Another table is the interface table. It's going to show us what interfaces are participating in the EIGRP writing process. We can say show IP EIGRP interfaces to see the contents of that table, and we see that on R1, loopback 0, Fast Ethernet 0/1, and serial 1/0, they're participating in EIGRP. The third table that EIGRP maintains is the neighbor table. We can see what neighbors we have by doing a show IP EIGRP neighbors command, and we've got 2 neighbors. We've got R2 and we've got R3. And one final command for you, and that is show IP protocols. It's going to give us a wealth of information about any IP routing protocols that we have configured. Here we see that we are using EIGRP and we're in Autonomous System 100, and that's something to watch out for. If your neighbors are not forming adjacencies, it might be because they're configured for different autonomous systems. We can also see the K values. The K values have to match between our neighbors, or else that neighborship, that adjacency will not form. We can see what our router ID is, and if we did have a passive interface configured, or if we were doing auto summarization, we could see that in this output. And this output is also showing us what networks we're advertising. In this EIGRP trouble ticket, we seem to be having an issue with router R3. We don't seem to be learning any networks from R3, and R3 doesn't seem to be learning any networks from R1 or R2. Let's do some verification to make sure we understand the issue. If I do a show IP route on R1, notice that the loopback IP address of R3 is missing. There's no route to 3.3.3.3. And also notice if I'm going down to R2's loopback interface of 2.2.2.2, I would expect to go over to R3 and then down to R2. In other words, I would prefer to stay on the LAN instead of going across a WAN link, but this output is showing me that I'm going over that serial link. And if I take a look at my EIGRP topology table, show IP EIGRP topology, I only know about one route to get to these networks that I know about. While previously, when we were using this topology, I would see a couple of routes to get to some of our networks. So we don't seem to be learning anything from R3. Are we a neighbor with R3? Let's check it out. Let's do a show IP EIGRP neighbor. I'm not a neighbor. I only have one neighbor and it's R2. Let's take a look at the EIGRP interface table. I'll do a show IP EIGRP interfaces. Looks like all of my interfaces are participating in EIGRP. And while we're here on R1, let's take a look at the configuration on R1. Let's take a look at the output of show run. Do we have any strangeness going on under Fast Ethernet 0/1? I was looking for things like authentication that might be configured on one side but not the other side. I don't really see anything there. We have a dual stack configuration. In other words, we're configured for both IPv4 and IPv6, but that's okay. And here we see the EIGRP router configuration for IP version 4. Here it is for IP version 6. We're focused on IPv4 right now, though. Those network statements all look fine. Well, I've shown you the output of this config on R1. Without giving a lot of commentary, I want to show you the same output on R2 and R3, and then invite you to pause the video and hypothesize what's going on here. Let's go to R2 and give a similar set of commands. On R2, we'll take a look at the IP routing table. Again, feel free to pause the video at any point if you want to interrogate this output. Let's take a look at our three EIGRP tables. I'll do a show IP EIGRP topology, show IP EIGRP neighbor, and finally show IP EIGRP interfaces. Oh, and one other command that might be useful. Let's take a look at show IP protocols. And I'll go over to R1 and we'll give that same command. We'll do a show IP protocols here as well. Again, pause the video if you need to at any point. We might want to look for things like matching K values. Let's go to R3 and give the same set of commands. On R3, let's do a show IP route. Wow, doesn't look like we've learned anything via EIGRP. Let's do a show IP EIGRP topology, show IP EIGRP neighbors, show IP EIGRP interfaces, and show IP protocols. Oh, and I'll also do a show run here on R3. Since that seems to be the router that's giving us issues, we might want to take a close look at the running config. There we have our network statements. All right. You might want to pause the video now. In fact, you might want to back up the video to different parts of the output and do some comparisons between the router configurations and see if you can find a reason why router R3 doesn't seem to be advertising or learning any routes via EIGRP. In fact, why router R3 is not even a neighbor with R1 or R2. And we'll see you back with the solution in just a moment. As you were going through the output, did you notice that the autonomous system was different on R3 as compared to R1 and R2? This would not have been an issue with OSPF. With OSPF, this number, as part of the router command, it was a process ID. However, with EIGRP, it's an autonomous system and it has to match between neighboring routers. Now, I wanted you to check for things like matching K values. I wanted you to make sure that we had all the network statements that we needed. I wanted you to make sure that we didn't have any passive interface commands that would have been preventing an adjacency from forming. But this was the issue, and we saw the autonomous system in the output of just about every command we gave. It was here in the running config, and if I do a show IP EIGRP neighbors, you can see that we're talking about autonomous system 10. Show IP EIGRP interfaces mentions autonomous system 10. Show IP EIGRP topology tells us we're in autonomous system 10, and show IP protocols tells us we're in autonomous system 10. So we had plenty of opportunities to see the autonomous system, and you should have noticed that it just does not match up with the autonomous system on R2, which is 100, or R1, which is also 100. How do we fix it? Well, the network statements were actually correct, so I'm going to make a copy of those network statements. Let's do a show run, pipe to section router EIGRP. It was 10 on this router. Just so I don't have to type these commands in again, I'm going to copy the network statements. Then let's create a new EIGRP routing process as part of Autonomous System 100. We'll say router EIGRP 100. I'll paste in those network statements. I'll get rid of the incorrect autonomous system. I'll say no router EIGRP 10. And we should have formed adjacencies now. And it looks like we have. Let's do a show IP EIGRP neighbors. And we have two neighbors. Show IP EIGRP interfaces shows us that all three of those interfaces are participating in EIGRP. And show IP EIGRP topology should show us more networks than just connected networks. In fact, let's go back to R1 where we started. We noticed initially on R1 that we could not see the 3.3.3.3 network, the loopback interface of R3. Let's do a show IP route. Can we see it now? We sure can. We have now restored connectivity, and the issue was the autonomous system number on R3 did not match any of its neighbors.